So when you have a symbol written like that, the bottom left subscript, that number is the atomic number. That's going to tell you the number of protons. That tells you what, that goes right here. That tells you what element it is. Iron's always going to have 26 protons, always going to have an atomic number of 26. All right, next, this number up here to the top left, that's your mass number. That's going to be the number of protons plus the number of neutrons. So what you have in those two spots, that's going to add up and give you that number on the top left. Now, the charge goes on the top to the right. The number and the charge, positive or negative, that's going to be the net charge. So what you got in that spot is going to match the number top and to the right. And that number is going to come from the balance of the electrons and protons. Because protons are positive, electrons are negative. If the number of each are not equal, then you're going to have a charge of some sort. All right, let's do it. That 26 tells us there's 26 protons. Iron always has 26 protons. And then these two numbers, the neutrons and protons, added to 53. So you can take the big number, the mass number, minus the atomic number, the small number, and that will give you the number of neutrons. All right, 53 minus 26 is 27. Okay, number of electrons gives you a net charge of 2 positive, so let's slap that right over there. It means you have 2 more protons. All right, so don't change the number of protons. That changes the element. Some students do that. That's a big no. Don't change the number of protons. That's got to match the element and the atomic number. So we can lower the number of electrons, so we end up with 2 more protons. So it must have 20, write that a little smaller, 24 electrons. All right, moving on, same thing here, 26, it must be iron, that's big F, little e, put the atomic number down there. Now, 33 plus 26, give you the mass number, that's 29. Sorry, no it is not, that's 59. All right, charge right there, let's slap that right over there. All right, it's got 3 more positives, it means it lost 3 electrons. Must have 23 electrons. All right, 85, let's take a look at our periodic table, which is ordered by number of protons, or the atomic number. All right, big A, little t. All right, 85, as the atomic number goes down there, the number of neutrons plus the number of protons, going to give us the mass number. All right, let's do a little math here. Carry that, that's 210, looks like. 210, yep. This one has 1 more electron than it does proton. So it has a net charge of 1 negative. Now we don't write ones in chemistry in the symbol, so let's just put a negative sign there. All right, that's 13. All right, that is aluminum, big A, little l. 13, atomic number goes down there. 13 plus 14 is the mass number, that's 27, that goes up here. All right, it has 3 less electrons. You can also say 3 more protons. So it has 3 positive charge. Metals like to give up electrons. They'll often form what we call cations, which are positive ions. All right, now this last one's a little, all right. We've been relying on this number or the atomic number somehow with number of protons, so we'll have to figure that one out. All right, we can do that. There's 54 electrons, because remember, the protons and the electrons are what determine the charge. So if we know the charge has 2 more electrons, that's how you get a 2 negative charge. So this must be 52. And now that we know the protons, we also know the element, because the number of protons tell us the element. So big T, little e, 52 goes down there. Protons plus neutrons give us the nucleus, or the mass. All right, almost done here. No mistakes. 8. 7 plus 5 is 13. No, it's not. See, I almost did it. 12. Let me check the periodic table. Pressure's on. Yeah, 128. And slap the charge right there.